Hello friends, today we are going to see the topic method study in the subject Industrial Engineering and Management. I am Professor K. Kalidas to handle the session for you. So before getting into this topic, let me have a quick review of the previous lectures which I have taken to you. So the first lecture was talking about the production and productivity. So what are the types of production systems? What are the types of productivity and its concepts? The lecture 2 was discussing about plant location and layout. So inside a industrial environment, what are the types of layouts that we can have, like product layout, process layout, mixed layout, and group technology type of layout, and what are the criteria are necessary for locating your plant. Suppose if you are establishing a new plant at the first time, what you have to do, and if you want to expand your industry, then what you have to do. So all these things we have seen in the lecture number 2. And lecture number 3 we have talked about factory building. So it means that where you have to locate your factory, how many story buildings that you have to have, and inside a factory what are the equipments and necessities are established, how it is going to be established, and all this we have seen. And in the fourth lecture we have seen about make or buy decisions. So whether to make a product by myself or whether I have to buy it from the outside sources. So making, again, it involves some factors like I should have all the resources, my labor resources, material resources, everything should be available with me for making a particular product. And I should have a capability to expand my products to outside world. And buying, again, for smaller parts like nut bolts, etc., you can buy the products, and which one is comparatively cheaper to establish whether it is going to be a making or whether it is going to be a buying. So how we have to make the decisions. Then lecture 5 we went for process planning. So again, manual process planning we have went for computerized process planning, where we had a generative type of approach, and we have a in manual process planning, how the planning has been made to allocate your resources for each and every machines, how the labors are have to be allocated to machines, and all that we have seen, how we have to plan the entire manufacturing process, that we have seen in the lecture 5. Then lecture 6 we have talked about the group technology. It means how you are going to divide your entire lot of products into uh, groups, like whether it's maybe a manufacturing attribute or it may be a design attribute. So you are going to divide the product based on circular and as well as rectangular products, or based on the machining that you are going to do, how you are going to split, and how the coding has been given. So that all we have seen. So we have seen one type of coding where you had each and every number indicates the profile of the particular product. So all these lectures we have completed in this particular subject so far. So in this lecture, we are going to talk about the method study. So method study, it is a process in which you are going to identify a appropriate method for manufacturing a particular product. This is what is going to be done. It comes under work study. So first we have to know what is meant by work study. Then we'll go into what is meant by a method study. Right. So this work study is divided into two techniques. One is method study and another one is work measurement. So what is work? So the process of manufacturing is nothing but the work that you are going to do. Say for example, you are going to study for your examinations. So first you should understand what is the methodology you are going to adapt for your studies. You are going to prepare for your examination. What are the various methodologies? Say you can read it by the book, you can browse through the net, you can refer our websites for lecture notes, or you can have written materials, or you can prepare some charts for easy memorizing the concepts. So you can have a lot of methods. So our final outcome is going to be our education or whatever maybe the marks that you are going to get. So in order to get that particular work to be done, what is the methods that I am going to adopt? So that is the method study. Then second one is the work measurement. So in the education process, is it enough for me to study up to a level? So what level I have to study? Say if I'm aiming to get 100 marks in mathematics, say for example, then how much efforts that I have done to get that particular mark? So I have to measure my work. So there are two things: what methodology I have adapted to get that product to be manufactured, and how much work has been done by each and every labor and each and every machine to get that particular product. So two things. So these two combine together to give the work study. So I know the method of work and I know how much I have worked. So both the things have been studied. So as per the British Standard Institution, it is defined as a generic term used for the techniques, method study and as well as work measurement, which are used in the measurement of human work in all its contexts. So you are going to measure what a human is going to do in various methods and you are going to measure it. And you are going to systematically investigate the factors which is going to affect the efficiency of the situation. So I have been given with a product. So what are the problems that I have faced if I want to manufacture that particular product? How I am going to tackle the situations? So what are the factors which is going to affect me? How my efficiency can be improved? All this comes under the work study process. So if in an industry, work study plays a very major role. So again, to list out some of the purposes, so it investigates the work done in an organization. So in a manufacturing process, right from the entry of the raw material till it reaches outside as a final product, what are the entire work it has been done. So it investigates each and every point at which a work is being done for manufacturing a product. Then it aims for the efficient use of the resources. So your labors or machines or your time, everything is going to be a resource as far as manufacturing is concerned. So it is going to say how efficiently you have used your resources. Then it it also helps you to make a quality product in a minimum time possible. Then what are the maximum manufacturing process that can be involved? How to reduce the fatigue of the workers? If you have unnecessary movements inside of the product inside the company, then how it can be eliminated? How you can sequence a particular set of operations? Uh, how I can handle the materials from one machine to the other machines? All this that I can. So you can even measure the skill of a person who is going to be working over there. Say, for example, a person who is joined new can make a turning just by 5 minutes, but an experienced person, he will make it within 3 to 2 minutes. So it means how much is the worker is been skilled enough to do that particular job. That is also been done by the purpose of work study. Again, advantages, again, whatever the purpose is been satisfied as the advantages. So uniform and improved production flow, higher productive efficiency, reduced manufacturing cost to achieve fast and accurate delivery date, better employer-employee relationships, then better service to the customers, job security and satisfaction, working conditions are made better than high wages to the workers. So it means if you have a standard procedure of doing a particular work, then whatever may be the possible advantages that I can get. So every possible advantages that I can obtain if I establish a work study. So again, this work study can be applied anywhere, even for your educational purpose, as I said as in previous example. So you can measure your performance or you can measure how much you have studied by some means, and you have to adapt various methods. If I'm not able to memorize a particular circuit or a particular diagram, what are the other methodologies that I can incorporate to memorize a particular thing? Suppose if I have a longer derivations, how I am going to split my derivations to memorize is better. So everything is going to be a method. So you can apply this work study at any process. It may be a production, it is R&D, sales, marketing, material handling, transport, army, hospitals, etc. This is simply nothing but a scheduled process of how to do your work. So you can apply it in any of the following applications. Okay. So now we come to the first part called as the method study. The second part is going to be the work measurement. So now, so it is defined as a systematic investigation of the existing method of doing a job in order to develop and install an easy, rapid, efficient, effective, less fatiguing procedure. So just I am repeating the word again. Anyway, you are going to do the job, you are going to manufacturing a process, but you are trying to install an easy way for manufacturing it, a quicker way to manufacturing it, then in an efficient manner you have to do it, then it should be effective enough for, that means in terms of quality, it should be effective enough, and also it should be less fatigue to the employer who is going to do the job. So anyway, you are going to make a product. So you have to do it in an effective manner, efficient manner at lower cost. So this is what is the idea. So in order to obtain this objective, what are the things that I am going to do? So it is achieved by eliminating unnecessary motions in a certain procedure, either by changing the sequence or changing the layout. So any time is being delayed because of unnecessary motions inside the industry. So a product which is going to come in is going to go out as a final product. It has to move for a very shorter distance inside the industry before it converts into an output. So either I can change the sequence of my movement or I can change the layout. It means that I can replace my machines at various positions so that the a quicker movement of the materials that I can obtain. That's what is the idea behind it. So this method study is mostly concentrating on how to eliminate this unnecessary motions. Say you have 10 machines. A product need not go to a process under all these 10 machines. Sometimes only 5 machines can be used. Sometimes only 3 machines can be used. So how you can utilize this other 7 machines, that also we have to see. And also, if these machines are placed at different locations, what will be the time travel between each and every machine, that also I have to keep it in mind. So if there is any possibilities to reduce this timing, I have to do it. So method study is going to eliminate the unnecessary motion of a particular product inside the industry. So that's what is the main objective. So what is the procedure that I am going to adapt for a motion study? So first I have to understand what is the product that I am going to take. So it is meaningless that if a product is going to work under 1 or 2 machines, then it is meaningless to adapt a method study procedure. Because anyway, that product needs the 2 machines for working. So it has to undergo the 2 process. It has to go out. So I should select the work, or I should select the job correctly so that a method study can be adopted. So at least it has to travel at least for 5 to 10 machines, and it needs some timing for manufacturing. All this has to be there. So first I have to select the work or the process, whether it is worth enough to go for a method study or not. This is the main thing. Then what is your objective? So this objective varies from industries to industries. Some industries have an objective of giving a good quality. Some industries have an objective of reducing the manufacturing cost. Some have an objective of reducing the fatigue of a worker. Some to avoid, yes, avoid the bottlenecks. It means that avoid the troubles which is going to happen inside the industry. So if you are selecting a process, in that process, what you are going to get optimized, whether you are going to optimize your timing or whether you are going to optimize the efficiency of a worker or whether you are going to reduce the cost. So you have to select the work or the process and its parallel objective that you have to select. Then what happens? You have to go for a survey. Survey in the sense you are going to record all the informations. So right now a process is going on. I have selected a process and this is what is my objective I have made. Now I am going to look after what is the original process is going on. How many persons are working? How many machines were there required for this particular process? What is the methodology that is being used? So everything is being analyzed by means of a chart. So why charts was, it is easy to understand. If you are writing it as a very big theory, then it is every time if you want to adapt a new method, then it is time taken. The time will be taken much to make it as a procedure again. So if it is in terms of charts, symbols, etc., colors, etc., then it will be easy for me to diagnose it easy. So if I see a particular color, okay, this material is waiting. If I see a particular symbol, okay, this product is under a transport. So if there is a delay, again, I have a particular symbol for doing it. Again, if I have a particular shading, I can understand what is the material was. So everything is being understood by means of a chart. So the existing procedure is analyzed by means of a chart. Now, you have to note down the critical events. So what is this critical event? Say, again, I'm parallelly using the example of education. No, I'm not getting the marks. So this is what is my problem is. My objective is to get good marks. Now I have to know what are the methodologies that I'm using right now. So what are the ways and means I'm studying now, where I am missing. So this recording the events critically means where you have the exact problem, where you have the exact issue is. Say suppose if you want to reduce the time taken for travel inside the industry. So I should know between which two machines is the time is taking delay. So is there any sequential issues in that? Who is the responsible person for this delay? If I know that, then what happens? I can make it a method to eliminate that particular bottleneck alone. So I have a problem at one particular place regarding the time. So in that particular area, how I can optimize this time? So for that, what I have to do, I have to gradually study each and every step where the problem is. So I have to critically analyze what are the records or what are the things that has been done, and I have to try to find a source for elimination or simplification of this particular problem. Okay, so this is the idea. Now you can have any methods. Suppose to solve a problem, you can have multiple methods. Now you have to analyze what are the methods that I can adapt for that. Then I have to develop a best method which should be practical enough to adapt. Then what is feasibility? I have to study safe, economical, and acceptable. So I have to keep in mind all these factors in my mind before developing a best solution for it. Then install the best solution and go for periodic check. So now again coming back to education, I'm not getting marks. So I'm going to adapt a lot of methodologies for memorizing a particular things. Either I may memorize or I can understand a particular concept. Then how I can enhance that education methodology. So that is the procedure which is being adopted in the method study. So simply speaking, analyze where is the problem, correct it. That's it. So what are the recording aids? So I said you. So if you want to analyze this particular methods which is happening, I have to go for charts. So what are the various recording aids that I'm using in the method study process? So basically it is divided into three types. One is the process charts, motion and film analysis, and next one is the diagrams. So in this particular section, we are going to see about the process charts and as well as the motion and film analysis. So in my next lecture, we are going to continue with the diagrams and as well as the time study. So there we are going to continue that. So in this, we are going to see what are the various process charts are available or utilized in the industry to indicate the present working methodology. So if I know that, if I'm able to present my methodology inside a particular chart, then it is easy for me to correct it if there is any bottlenecks. So this is the idea behind it, right? So this process chart again gives an outline process chart. So outline by the word itself, you can say it's a broader perspective. So it means that it is not going to critically analyze the deeper things or a very smaller activities. It's not going to analyze. It is going to say an outline. It's going to give you only an outline of a particular process. So where it is coming, where it is going, what is to be done, and etc. So that's what is going to be done as a outline process chart. In flow process chart, you are going to handle how this process flows, where this machine, which machine is being used, how it is being used, what is the flow from which machine to which machine the product is going to move. So all this we are going to see. Then again, going deeper, we are going to go for two-handed process chart. It means that while doing a worker, how he is utilizing his left hand and right hand for doing that particular job. So, although it looked like a very simple thing, it is very critical to analyze that particular activity. Say, for example, if you are working in a CNC machine, if you have an experience of working in a CNC machine, how you are going to utilize these two hands? So normally when you just, if you are a right-handed, you are going to just open up the window or open up the door of the CNC machine, just you are going to install, you are going to program it, that's it. So at the most of the activities, your right hand only will be used, your left hand will be idle. So is there any opportunities for your left hand to do any process? That we have to check. If there is any methodology that can be adapted to use your next hand. So that critical analysis is done by the two-handed process chart. Then multiple activity chart. Say a person who is working in two CNC machines, say for example. So what happens in a thing is going to program it, he is going to just give the workpiece, he is going to run the program. Say this program is runs for say 20 minutes. So this 20 minutes, this person is going to be sitting idle if he is going to work in a single CNC machine. Suppose if he has two CNC machines, he has been allocated a work for two CNC machines, then what he can do was he can program a particular machine, then he can utilize that 20 minutes for programming and doing the work in the next CNC machine, so that the machine utilization and the labor utilization can be parallelly enhanced. So that is the idea. Then travel charts. Travel charts, again, it is going to concentrate on what is the distance traveled between each and every machines, and how much product has been transferred from one place to another. So if you have five machines, so between these five machines, how many products are going to travel, at what time it is going to travel. So whether I can have any layout arrangement so that I can have a less travel. Travel in the sense is again going to concentrate on the quantity traveled and as well as the time traveled. So that's going to be. Then motion and film analysis, again, it's as the name indicates, it's going to be by means of a camera. It's going to analyze what is your work done by each and every limbs actually. So they are not going to talk in terms of hands, they are going to talk in terms of limbs. So how it is being utilized, so how this can be enhanced. So when you see all these words, you are just trying to analyze the wastage, either the wastage time or wastage machinery or whatever you are trying to answer. Then diagram in the sense flow diagram. So what is the travel flow that's going to be indicated by a diagram? String diagram is there. So that's all we will see it in the next session deep. Okay. So suppose if you want to install this entire activities inside a chart, we have to use the symbols. Because again, you cannot write a theory inside the chart. So you need in terms of a symbol. So basically, you are going to have 5 symbols and a combination. So this 5 symbol says, a circle symbol says an operation. So it may be anything. It may be a turning, phasing, or cutting a bar, or you are just opening up a coolant bottle. You are pouring the coolant, any operation. So anything that you are going to do is going to be an operation. So it is indicated by a circle. Then second one is going to be the storage. So it means that where is your raw material, where is your finished product, whether the product is been waiting for you. So where is that product is? That is what is called as the storage. It may be in terms of panels, it may be in rooms, it may be in cabins, it may be of any shape, but any storage is called as the, or it is being indicated as the triangle symbol. Then comes the delay or temporary storage. It means that due to a power failure, a material can wait for a particular machine, or because of the delay on the previous machine, a machine can wait. So either the person or the machine or the product, anything, if it is going to wait at a particular point, then it is called as a temporary storage unit, or it is called as a delay period. So that is indicated by the letter D. Then if the product is in the action of traveling, then I can say it is going to be in transport, which is indicated by an arrow mark. So this arrow mark, again, it can be of uh, northwest, east, south, anywhere you can indicate that. It need not be only towards your left. Then inspection, again, it's going to be a square symbol. So it is going to inspect whether it may be a CMM, it may be a manual inspection, it may be a checking any quantity, it may be checking a shape, it may be checking the characteristics, anything it can be. So this five symbols, that is circle for operation, triangle for storage, D for delay, arrow marks for the transportation, I and I for the inspection. So these five are going to happen inside the industry. And you can have a combination. So combination in the sense, as I have indicated, yes, a arrow mark inside a circle indicates you are going to have the transportation and operation simultaneously. Say, for example, you are going to transport this material through a conveyor. So during its travel, you are trying to paint it. Just it's for an example. So the product is under transport, that is indicated by a arrow mark. During that time, you are going to do an operation. So again, during the transportation, I can do an inspection. It means that inside a square, I can have a arrow mark. Then operation come inspection that I can have. So while you are measuring, say for example, sometimes in the lathe machines when you are measuring, when the product itself is running, you can measure something. You can even measure the speed at which the lathe, the workpiece is rotating. So all this you can do. Either by using a digital tachometer, you can just measure what is the speed at which a product is going to rotate inside the chuck of the lathe. That you can do. So you can combine these five processes at any combinations that you can do that. So these are the basic symbols that are used in the process charts. So next one is going to be the outline process chart. So as the word indicates, it is going to give an overall picture. Just it's going to give an idea of what is the process and what are the major steps involved in it. So it is not going to go in a micro manner. It's not going to analyze each and every step of movement, each and every movement of the hand. Not like that. It is going to give only a broader perspective of what is going to happen. Say, I have given a very simple example of just replacing your refill inside a pen. So just remember the symbols. A circle indicates the operation, a square indicates your writing, D indicates a delay, transportation, all this is going to be there. Now when you take a product, a pen, then what you are going to do is just you are going to remove the cap, you are going to remove the neck of the pen, then you are going to remove your old refill, you are going to assemble the springs, then you are going to refill inside the barrel, then you are going to screw the neck. After screwing the neck, you are going to check it because we want to know whether this refill is writing or not. So you are going to check it, then again you are going to screw your cap. So this is a simple example of a daily process. So the same can be applied in a manufacturing process also. So what are the entire steps? Say a product is coming, so transportation. So transportation is indicated by a arrow mark symbol. So it is coming from storage. That is, it's a triangle. So from a triangle, arrow mark can be drawn. So that what happens, it indicates the product is going to come from the storage to it is going to transport. Then inside a machine. So again, you can have a symbol. Then after machining, you can have a triangle to inspect whether you have done it or not. After that, you are going to put it in a conveyor. It is going to travel. So the entire process as an outline, you can just have it. So it's going to say what are the things that you are going to do as an outline. So next one comes the process flow chart. So this process flow chart indicates what is the sequence by using the process symbols, what is the distance moved and what is the time taken. So it is going to indicate what is the distance moved, time taken, and as well as what are the symbols that I can do. So again, it can be of man, equipment, and material. It means that how a man is going to flow for making a process, flow in the sense how he is going to behave or what he is going to do. A man who is going to sit idle, so again, waiting, you can say delay. A man who is going to do an operation, then you can say it's a circle. A man who is going to inspect, you can say you can give you a triangle, you can give you a rectangle. Similarly, going for the equipment, an equipment again it can have its own operation, it can have its own checking, it can have its own delay, all that. Due to power fluctuation, due delay time can happen. Due to the processing, some delay time may occur. Then materials, how this materials is going to. So I have given an example of material type of process chart. So again, so the activities are listed at the left hand. That is casting in foundry. So it is in foundry. It means that you are going to have it as a storage. So that is indicated by a triangle symbol. So in the storage, you are not going to have any distance moved, or you are not going to take any time taken. So it is going to be available in the log. It is going to be available inside the foundry. Now this casting is going to the gas cutting machine. Now this is indicated as a transport. So my storage is indicated as a triangle. Now the transport is indicated by a arrow mark. So if I indicate the transport, I have to indicate two things: how much distance it is moved and what is the time taken for its movement, and how you have moved it. Whether you are going to carry by yourself, whether you are going to give it by trolley, conveyors, lifts, whatever it may be. So here you are going to say from the storage, when it is going to the gas cutting machine, what is the time taken and what is the time taken and what is the distance moved, and it has been done by a trolley. Right. Now the product is in the gas cutting machine. Now what happens was this gas cutting machine has to be made a setup. So for this setup, again the gas cutting machine is not going to move. So again the product is not going to move. It is going to be near the gas cutting machine, but it is going to have a time delay. So here the distance is going to be 0 and you are going to have a time delay. Say for example, I have given 5 minutes for setup of that particular gas cutting machine. So as a product, I am going to wait before the gas cutting machine for 5 minutes. Then I am going for an operation. Again, during the operation, again you are not going to have any distance moved. You are going to have the time. How much time is required for making this operation? In remarks, if you want, you can say by which machine you can do that. Either what in CNC machine you have done it or lathe machine you have done it. So you can just give a remark of how this operation can be done. Since it's a gas cutting machine, you can say just by using the gas cutting machine you have done it. Then moved and stored. It means that after doing, it is going to move and stored as a finished work piece. So here I have a combination. So it is going to move and store, move and store. So I'm going to combine this triangle along with a arrow mark. So again, what is the distance moved and time taken for this? So here I can analyze. So for this process of gas cutting a particular casting, I want to travel for 30 meters along with a time period of 33 minutes. So that is the idea. So if I know this, then I can concentrate where is my time or the distance is high. So if I go for a optimization of a distance, then I have to analyze this particular part of moving and store. So it is taking 20 minutes. So 20 meters to travel. So how it can be enhanced? Then 20 minutes are required for making this cutting operation. How it can be enhanced? So just by seeing the chart alone, I can have an idea of what the process has to be optimized here. Say again, with respect to a human being, with respect to a person. So the idea is going to be an inspection process. Say I am the person who is going to inspect a particular process. So what I'm going to do is first I'm going to receive the goods for inspection. So from the manufacturing, it is going to come to the inspection department. So first I have to receive. So what I'm going to do is I'm going to go in person to receive that particular component. That's why I've indicated in the arrow mark. Then I have to locate. It means that I'm trying to find out where is my component, what are the components that I have to do it. Then pick up one particular component. So I have to select the lot. Say for inspection, say 10 lots may be coming. As an individual person, I want to select one particular lot. So I have to locate which lot I have to just inspect. Then from that I am going to take a component. Then I am going to go to the inspection place where I am going to check it. Then for inspection, again I need some formality has to be done. So we have to set the component into the bench, or you have to set up inside the machine. Then you have to go for an inspection. So inspection may be either it may be a surface or it may be a dimension, anything. So if you want to measure the length, just to record this particular length, then you have to say this length has been inspected and it's found to be correct. So you have to give a seal. Then it has to be go to the stores and it has to return. You have to return to the department. Now what happens was a man is going to do all this work. So in the previous case, the material, in the point of view of the material we have spoken, here we are going to talk in terms of the man. How this labor, a single labor is being working. Whether he is moving or whether he is in delay or whether he is going to do any operation, whether he is going to inspect. So everything in terms of, in the point of view of a labor we are going to talk. So next process is going to be a two-handed process chart. This is what I am talking about. It is going to record the activities of both left hand and the right hand during a particular process. So say I have given a simple activity, just assembling the nut and bolt of a right-handed worker. So this is what is the job is being given to him. So just imagine this particular situation. You are a right-hander. So imagine this situation. You are going to assemble a nut and bolt. So what you will be doing is, you will be picking up the bolt in the left hand. During that particular time, your right hand will be idle. So again, the corresponding symbols I have given. So idle in the sense it's waiting, so it is going to be a delay. So the right hand is going to be idle delay, and you are going to do your work. That is, you are going to pick up the bolt, so it has been indicated by a circle for the left hand. Now your left hand has got the bolt. Now the nut you have to take. So obviously you are going to use the right hand to take up the nut. So you are going to take up the nut by the right hand. So at that particular time, with the nut, your left hand will be, sorry, with the bolt, your left hand will be idle. Now, your nut and bolt are available. Now you are going to assemble it. So obviously you have to move a hand because both the hands are far together. So you have to move these hands to nearby position so that this nut and bolt can have a assembly. So I just move, in this case, I have moved my left hand towards my right hand. Then I am trying to assemble. So here, for a simple process, I have indicated 4 steps to say how your right hand and left hand is going to behave for assembling a nut and bolt. So just imagine the same process for a manufacturing thing. So a product has come, he is standing before a lathe. So at each and every point, how his left hand and right hand is going to behave. Obviously, it is going to be a reverse process, vice versa process for the left hander. So you have to indicate the nature of the hand which the worker is going to do. So why this? Again, as I said, how is there any possibilities to use your next hand for a better process? So that's the only idea. Then goes for the multiple activity chart. So you have multiple machines and a single labor, how you are going to allocate this particular machines and labors accordingly. So just I'm going to show it as an example. So look at this diagram. So I have 2 machines and 1 operator. So assume the situation correctly. So I am going to have 2 machines and 1 operator. Now there is a scale which is given between 0 to 45, say in minutes. Now what happens was a single operator is going to operate 2 machines. So for the first 5 minutes, obviously the worker has to set the machine 1. So the operator is given in red color and the machine is indicated in the blue color. So this operator and machine is busy for that first 5 minutes, that machine 1 and the operator. During that time, the machine 2 will be idle. So obviously we cannot avoid it because he is a single operator who is going to operate the 2 machines. So for the next 5 minutes, what happens? This particular guy is making the machine 1 to operate by itself, and he is going to set up the machine number 2. So the operator is indicated by red color, the machine setting is given by blue color, and the working is being given in green color, and the idle time is given in white color. So first 5 minutes, again the machine 1 is being set up and it starts operating. Then 5 to 10th minutes is going to set up your second machine. Then the next 10 minutes, just to see the machine 1 and machine 2 are both working. I have been given with 2 machines alone. So from 10 to 20, both the machines are going to be working. So I don't have any job, so the operator is going to be idle. So the operator is going to be idle. Then once the product is ready in the machine number 2, he is going to disassemble. So it means that 20 to 25, he is going to operate that particular, he is going to set up this particular machine. He is going to take out and replace the other product, and it starts to running. So in between, what happened? The machine 1 comes into the picture. Now when you see this particular chart, you can identify how much period they are between in this 45 minutes, how much minutes a worker is working, how much minutes a machine is working, how much minutes a machine 2 is working. So just I am going to give it as a tabulation. The resources are going to be operator machine 1 and machine 2. So at a span of 45 minutes, the working time of an operator is going to be 25 minutes and the idle time is going to be 20 minutes. Now, what is my idea will be was how to utilize this 20 minutes, because 20 minutes is a larger time. So whether this person will be allocated with a very smaller work of maybe inspection work or some other work in this 20 minutes to utilize these resources effectively. Then machine 2, again, it's been fully utilized. Either it may be set up or it may be in working. So either it will be working or it may be in setup period. So it will be doing. Then machine 2, except for the first 5 minutes of idle time, it's going to be working. So here I don't have any resource problem or working problem with machine 1 or machine 2. I have a huge 20 minutes of idle time for a particular work. So this idle time, again, it can be given for relaxation also, so to some extent. Say if this machine working is going to be very hectic, this 20 minutes can be given for a relaxation for this particular person. So this chart will clearly explain you the resource utilization of a particular product or in a particular industry, how these resources are being utilized. It is going to say you what is the working time and idle time of each and every machines. Just I have given 2 examples. So think of multiple machines that will be given to an operator. So you can analyze that. So then comes the travel chart. So travel chart is going to say what is going to be the amount of material handling between workstations. So I have 4 working places. How much material has been transported from one place to another place. So that's the idea. So I have given a simple chart here. So I have 3 parts. So the part 1 is going to be 200 components. Part 2, I'm going to have 100 components. Part 3, I'm going to have 300 components. It means that, say, 3 different dimensions of a product. So it is indicated by part 1, part 2, and part 3. So how many parts 1, how many part 2, and how many part 3 is being there. And what is the sequence of operations? So again, I'm going to have the machines A, B, C, D. So it is going to have a travel between A, B, C, B, D. The first product is going to undergo in this sequence. So first it is going to machine at A, then B, then C, then B, and again it's going to come to D. Then again A, C, D for the second product, C, B, D for the third product. So this is the particular table which we know. I know how many products are going to travel between what are the machines that is going to get operated, that I know. Now I am going to prepare a from to chart. So from to in the sense, say at the top I have given the from and at the left hand I have given the to. So it means that obviously the diagonals are not going to be coming because a product cannot move from A to A, B to B, C to C, and D to D. So that has been shaded as empty. Now listen, this 200, and let me take the first part, that is 200. So that 200 is going to travel from A to B first. So A to B in the sense I have indicated it by A to B. So A to B indicated by 200. Then again B to C, again I have indicated as 200. Then C to B, so C to B I have indicated as 200. B to D I have indicated as 200. So it is going to travel from A to B 200, B to C 200, C to B again 200, then B to D again 200. Similarly, I am going to do for the part number 2, that is 100 products. So A to, so from A to C, so that is 100. Then from C to D 100. Similarly, part number 3, C to B 300, B to D 300. So now what I know here was the transactions between each and every machine that I know. The transaction between A and B is going to be 200 always. The transaction between D and B, it is going to be again. So when you go for D and B, so it is going to be 500. So when you go for C, then C to B, then in the case I'm going to have 500 here and 200 here, so 700 here. So B and C is going to have the maximum transaction. So here this is going to be 500 and here it is going to be 200. So obviously what is your idea was you are going to keep your B and C at a reachable position because it is going to have mutual transactions. B and C is going to have mutual transaction of the products. So based on that, I'm going to prepare a chart. So this may be the optimum chart. So B and C is going to have the mutual correspondence. The other machines can be kept like this so that I can have the minimum travel. So this is what is the idea of going for the travel charts. Then what are its advantages? So these charts have its own advantages. So it is used to analyze the material handling and planning department locations, layouts, material handling procedures, whatnot. So all the processes, all the basic advantages that I can get out of a out of using a chart for optimization, then I can get it. So I can control the inventories, I can use the resources effectively so that I can reduce the cost. So the story remains the same for all that. Then comes to the micro motion study. So now we have studied about the major things. So how each and everything is going to move. Now we are going for a micro movement. Micro in the sense very smaller movements. So each and every smaller movements are going to be recorded here. So for recording, again they are going to use the chart. So that charts, again you are going to use some symbols. So that symbols are called as therblics. So therblics are used as a symbols for making this particular micro motion study. So sometimes what happens, this micro motion study will help you to enhance your manufacturing process, or it may be used to avoid the unutilized motions. So again, this is a concept given by Gilbreth. So it is going to describe the basic movements in a cycle. So it has been indicated by a particular symbol, color, and a word. So you are going to use the SIMO chart for doing that. So let me show you what are the therblics that has been used here. So these therblics are going to say what are the entire things that has been done inside an industry. So you can use the assemble, disassemble. So the corresponding symbol and the corresponding color has been given here. So what it is going to say. So assemble in the sense you are going to put the object, disassemble you are going to separate it, then avoidable and unavoidable delay. So which is under the control of process, then it can be said as a avoidable delay, which is unavoidable. So the operator is not responsible for this delay, then it is going to be unavoidable. Then whether you are going to have the transport loaded or empty. So whether you are going to move any part or any conveyor or any trolleys with product or without the product. Then searching. So searching in the sense you are going to spend a time to search a particular product. Say 1,000 products may be available at one particular place. How you are going to search it? So hunting for a object is indicated by search. Just you can note down all the symbols which has been given and the color corresponding to each and every therblics. Then planning. So it means that how you are going to do that particular machining, all the plans. Then resting. Then positioning. How you are going to where you are going to keep this products. Where is your coolant was? Where is your tool was? Where is your jigs was? All that. Then finding it. It means that sometimes you get overreacted after finding a particular product. So search and find is almost near. Searching is you are going to search and search in a bigger lot and find a found out. Then inspecting. So again, for quality it can be inspected. Then pre-positioning, it means that you are going to determine a position for a particular tool or a particular product. Then you are going to grasp it, you are going to hold a particular product, then using it, then holding it, then selecting a particular object from the menu, then releasing the load. So when you see, all these are very minor movements. So just holding an object, it's a very simple movement. So just selecting an object, it's a simple movement. Planning, it's a simple work. Then finding and thing, inspecting. So right from a bigger perspective to a very smaller perspective, now we have moved. So all this have its own particular symbols and as well as its own particular color to define what it is. So this rubrics are going to be utilized in the SIMO chart. So SIMO indicates simultaneous motion cycle chart. So simultaneous in the sense together or parallelly you are going to see. So you are going to analyze the movement of the limbs in the scale of wings. Wings in the sense it's a unit which is indicated by 1 by 2000 of a minute. So it means how your limbs are going to be moving at every 1 by 2000s of a minute. So analyze, just understand how depth I am going for a micro study. I am going to analyze 1 by 2000 of a minute. That is, I am going to call it by the word called wings. So I am going to record each and every movement by means of a wings. Now what is necessary for me? It is not practically possible to understand how this moves. You cannot understand how your finger moves in 1 by 2000 of a minute. It is practically not possible in a general manner. So what obviously you have to do is you have to record it. So for recording, again you are going to have a 16 mm movie camera which captures at 16 frames per second. And also you are going to have the wing counter. So it means that for each and every wing, how much, what are the works done. So it is being recorded by the camera. So from the recorded video, we are going to analyze what is the cycle that is being done, how each and every hand is moving, how each and every limbs is moving, everything. Then you are going to assemble everything inside a SIMO chart by use of a threbbling symbol. So now what I have said was it's a micro motion study. So for micro motion, you are going to have the time period of 1 by 2000. So 1 by 2000 of a minute, how it can be recorded was it can be recorded by a 16 mm movie camera. So with that camera, you can just analyze for each and every wink how your limbs are going to be moving. Then it's not always possible to indicate each and every wink. It means that it is always not possible to optimize each and every wink. So obviously what you have to do is you have to have a time period. It means that say for 50 winks, if a limb is free, then again you have to find the opportunities to enhance that. So obviously it is going to be a very, very minute or micro study procedure. So this is the model that I am going to use. So this SIMO chart is going to indicate who is going to be the worker I am going to analyze. What is the component he is doing? What is the operation? What is the film number? Film number in the sense, as I said, you are going to have a movie camera. So which film is going to record his motion? So what is the film number that I have to do? And whether it is going to be a present method or a proposed method. So what is this present and proposed method was? See, just by randomly selecting a particular person and just analyzing what is his motions. So presently a work will be going on, just you are going to analyze his performance, you are going to analyze the movement of left and right hands. So obviously it's in the working procedure now, so just you can record it. Or proposed in the sense you are going to train a person. Suppose you are going to newly train a particular person, then you are going to make him adopt for this particular SIMO chart. Say for example, I am doing a particular work and my limbs are moving in a particular direction in particular time period. Now, I am trying to enhance this. I am trying to optimize these movements. Now I have trained my workers so that I am saying that for 50 to 100 wings, your left hand is free. So now I have proposed a work for this particular 50 wings. Now it becomes a proposed methodology. So analyzing what is happening presently, and you are going to propose a new methodology in the SIMO chart. So again, you are going to have a tabulation. So again, time period in winks, it is for every 1 by 2000 of a time period, I am going to check it. So a simple process of grasping a hammer and a chisel. So left hand can have a chisel, right hand can have a hammer, and it can do a job. It can position it. It can use it. So whatever it may be. So you have a list of around 15 to 20 symbols that has been in the trebling. So I can use all these treblings to indicate the symbols, and you can indicate by use of a what is the description that you are going to use. So here the left hand and right hand for each and every wing, how it is going to behave. So right from this particular chart alone, I can say that 50 wings are going to be free for both left hand and right hand for this particular job. So here 20 wings, sorry. So 20 wings are going to be idle for the left hand and right hand. So is there any possibility for me to utilize this 20 wings? Since it's a micro motion study, again you can utilize it for the better manner. So that's the idea. So at an outset in this lecture, what we have seen was what is meant by work study. So work study is going to be a combination of method study and as well as the work management or work measurement. So how I am going to do that work and how I am going to measure the work that I have done. Then what is meant by a method study, where it is being used. So what is the entire procedure of making a method study? So you have to analyze the particular work and you have to make an objective. Then you have to record what is happening over there. Then trying for a new alternative. Then going and establishing the new alternative and checking its performance. So all this are done in the method study. Then various charts. There is process chart, again outline chart, which is going to indicate your broader perspective of the job. Then flow process charts we have seen. Then how you are going to use your two hands, that is two-handed right and left hand charts. Then you can have the man machine chart. It's meant that how you are going to utilize a particular man between these two machines. Just I have given an example for that. Then travel in the sense how you are going to utilize your resources, how you are going to modify your location of a particular machine according to the number of product traveling between the machines. So that is done by using the travel charts. And finally, we have seen about the SIMO chart, where you had a concept of trebling, where you had different symbols to indicate a micro motion of a human being or a labor. So by that, you are going to analyze how much wings has been wasted by him. So is there any possibility to utilize that particular wing? The example which I have shown is very simple. So just 20 wings are free. But for a huge process, a motion camera working for around 2 hours for a particular process, then you can have a multiple amount of wings that has been wasted. So trying to enhance that particular process. So in my next lecture, what I am going to do is I am going to talk about the flows symbols. So I talked about the process charts and as well as SIMO chart, and one more set is remaining, that is the flow charts. So how we are going to use that flow charts inside this? Then we are going for a time study. So time study indicates how much time. Now I have found out what is the methodology. Now I have to go to study how much time is required for making each and every process. So that is my next lecture is going to be. So let me look for any comments or any clarifications from your side. So is there any clarifications? I'm not able to see any clarifications or doubts in your chat box. Fine. So just go through all my videos that has been posted in the YouTube via Ekeeda. And if you're interested, you can purchase my videos and get help out of my lectures. Thank you one and all.